that. There, that's what the people get to learn, that, because I've already done it and I'm not repeating myself. Okay, so come to class. That's all I have to say. Okay, consider the following example. So this is our example here. 4 black counters and 5 white counters. They're saying counters instead of marbles, so at least you might have a fighting chance. Please put away your phones. 4 black phones and 4 white phones. We pay way more attention. 5. Yes. So we have 4 black counters, 5 white counters are placed in a bag. One of the counters is selected at random. So you're going into the bag and you're picking out one. It's in my hand. It's right here. Imagine it. Isn't it beautiful? I don't know. Is it black or white? I'm not quite sure. Well, let's state the probability that it's black. Yep. What's the probability that it's a black counter? 4 out of 9. Because what did we do when we do probability? The number of what we're looking for divided by the total. So on the top, we have number of black, and on the bottom, we have number of total. You are correct. Now, we want not black, so the complement of black. How many not blacks are there? 5 out of 9. What does the not black and the black add up to? 9 out of 9, which is 1. Because probabilities of complement events add up to 1. If I give you probabilities in percentage, what would they add up to? 100. So it depends on if probabilities in decimal form or if probabilities are in percent form. If probabilities are in percent form, they add to 100. If probabilities are in decimal form, they add to 1. Okay? So what we might want to write on the side here is the probability of B plus the probability of the complement of B equal what? What did you guys tell me? 1. If they were in percents, they would add up to 100. Yeah. So the events black and not black are called complement events. And the sum of the probabilities are equal to 1. Right? Can we agree? Very important, because often they'll give you the complement of something and then ask you what the other piece is, and you need to know they add up to 1. Okay? Or 100 if it's in percent. So, odds. The probability of black can be determined by the number of black counters over the total. So number of black over total, which was 4 over 9. The probability of non-black was 5 over 9. Right? We agree. We did that already. It is less likely, then, that a black counter will be selected than a non-black counter. Why is that? Why is it less likely that a black will be selected, than a non-black? Yeah. There's less of them. The probability of picking them is what? Lower. So how could we figure out the probability? Go 4 divided by 9 in your calculator, guys. And then put 5 divided by 9 in your calculator. So if I just say probability to the nearest hundredth, let's think about rounding. So if you forget what rounding is, think of it as how many zeros it has. So if you say round to the nearest tenth, how many zeros does 10 have? 1, so it's 1 decimal place. If it says round to the nearest hundredth, how many zeros does 100 have? 2, so 2 decimal places, okay? You just follow the number of zeros that it has, and you know how many decimal places. So if I said round to the nearest hundredth, 4 over 9 would be 0.44, and 5 over 9 would be 0.56. We agree? So I can ask this question in 2 different ways. I could ask for the probability of a black counter to the nearest hundredth. If I say that, I want 0.44, correct? But if I say, what's the probability of a black counter to the nearest percent, you would tell me 44. Very different on how you'd fill those into numeric response boxes, correct? So if I ask to the nearest hundredth and you give me 44, is the little bubble sheet going to go through and say it's right? No, I would need 0.44 because it just counts the bubbles, doesn't it? So you need to make sure that you read what they want to the nearest hundredth or to the nearest percent or to the nearest tenth of a percent. If it says percent, you have to take that decimal and multiply it by what? 100 to get percentage. Okay? All right. Now, we can say the odds for selecting a black counter is 4 to 5. Okay? So this is odds 4. Now, what you do when it says odds 4, you read what comes after it. So it says odds for selecting a black counter, okay? When it says odds for something, whatever they select comes first, all right? So it says odds for a black counter. So this is going to be a black counter, and this one's going to be a not black counter, okay? How many black counters were there? 4. How many not black counters were there? 5. What does that total to? 9. Now this is the catch. The probability has the total on the bottom, doesn't it? Does odds have total anywhere? So if I need the total from an odd statement, what would I have to do? Add the 2. So these two numbers, key to write this down because people forget, add to the total. They add to the total. So the total is found in a probability statement at the very bottom. The total is not found anywhere directly on an odd statement other than the fact that you can add the 2 odds up and get the total. Okay? Very important. People think that they add up, that the odds have the total somewhere in it. They don't. You have to add up 2 numbers in order to get the total. Okay? Now, if it says odds against selecting a black counter, odds against, whatever comes after that comes second. So this can be black counter. This can be not black counter. So that's why it's 5 to 4. So if it says odds against something, that comes second. If it says odds for something, that comes first. Okay? Odds for first, odds against second. Okay? Kind of makes sense? So let's look at this. Odds are normally expressed, and odds for or odds in favor mean the same thing. So you'll see both of these. Okay? More so you see this one actually. Odds in favor of. Okay? Odds in favor, odds against are usually what they say. Now, odds are normally expressed in a ratio of 4 to 5, but they can be expressed like this. They're not. On the diploma, they never express them as a fraction. But they can, from odds, you can express probabilities, right? So this says, this would be odds in favor of a black counter, correct? Odds in favor of a black counter would be 4 to 5. So which is the black counter, the 4 or the 5? 4, because it says odds in favor of black. So then it would come first, not black would come second. From any odds, I can ask you a probability very, very easily. Why? Because the probability, I need the number of that item over total. Do I have the number of the item here? Yes, it's both items. Do I have the total? Yes, it's the 2 added. So if from here I asked you, I could give you these odds, I could ask you for the probability of a black. You would tell me it's 4 out of how many total? 9. Probability of not black would be 5 out of 9. You could do that either way. You could take the black, not black over 9, or you could say, hey, probabilities complements add to 1. There's so many different ways you can do these that sometimes it's overwhelming because people want to know the one way. Well, just because you know one way and someone else knows the other way and you get the same answer, are either of you better? No. Whatever way gets you the right answer is better. Okay. So let's look at this one. This gives you a sum up. This is very important. So if it says odds in favor of A comes first. If it says odds against A comes second. This would be just like A prime. Here, this is A prime. Odds against A is A prime. Probability of A comes up here over total. Important, okay? If you understand these, it's actually a really, really easy lesson. If you don't, you just randomly put random stuff and it's really bad. Really, really bad. Or you get rules mixed up. Make sure your phones are away. I'm still seeing some phones up. And I'm working hard up here, so you should be too. So, what are the odds in favor? Does that mean comes first or second? Odds in favor. First. Favor first. of white. So what comes first? White. What comes second? Not white. We agree? Is this just another way of asking the exact same question? Yeah. How many white were there? 5. How many not whites? There were 4 that weren't white. The next one says odds against a white counter. Odds against means white comes second. And what comes first? So what happened? They just switched. Odds for and odds against. Here it says even odds are when the odds for and against are equal. So 1 to 1. So if you had had 4 white and 4 not white, you'd get 1 to 1. So that would mean you'd have equal odds of pulling out either one. Okay? Because you could have 4 to 4, but that would reduce to 1 to 1 because you could reduce it. Right? Okay. Example 2. After suffering a severe heart attack, Dudley's doctor told him that he had even odds of making a full recovery. What does that mean? 50-50 chance. What could we reduce that down to? 1 to 1. So we know that his odds are 1 to 1. His odds are 1 to 1 for, and his odds are 1 to 1 against, actually, because if I flop them, they're the exact same thing, because they're equal odds. Correct? So what's the probability he'll make a full recovery? Well, we have to decide. Do we want this to be full recovery and not full recovery? Could they be the other way? Yeah, it wouldn't matter. But they want the probability of a full recovery. Probability, full recovery. So we always read the word probability, and whatever follows after it is what we're doing. Okay? So we want probability of full recovery. Well, we know the probability formula. What's the probability formula? The number of whatever the heck you're finding, the number of full recovery in this case, over the number total. We agree? So how many F's are there? 1. How many total? 2. Why? How did we get a total from an odds? How did we get a total from an odds? You add them. This and this is the total. So 1 plus 1 equals 2. Odds always add up to the total. You can't forget that. People think that the total is in the odds somewhere. It's not directly in odds, but you can get it. But it's not. You're not going to find the total as a direct number pulling from it, right? But you can get the total really easily by adding them. Make sense? Okay. Stephanie has been told the probability that she will make a full recovery is 0.65. What's that as a percent? So what's that? 65 out of 100. What does that reduce to? 13 out of 20? See? Oh, this is getting worse. 13 out of 20. Shouldn't be that hard. Like that? Okay. So, that is the probability of a full recovery, correct? So this is number of full over the number of total. We agree? So what about the probability of not full recovery? Be 7 out of 20, because what should they add up to? Their complement events. They should equal 1. So if they're out of 20, whatever the remainder is, right? Now, odds. They want in lowest terms, odds in favor of a full recovery. Odds in favor. So odds in favor means full recovery comes first. So full recovery to not full recovery. The total is the number 20. Is that going to be anywhere in the odds? Like, am I going to have a 20 anywhere? No, I can't express that any more than that. People put it in there all the time. Or I give a question and I say, how is this wrong? And I have the total in the odds, and they're like, it's not wrong. This person rocks. They are amazing. If I asked how is it wrong, it probably is. So don't fight that they're super smart, okay? So this will total to 20. We agree? How many are F? 13. How many are not F? 7. What if we had done, instead of reducing it here, what if we did 65 over 100 and we had then 35 over 100 for this one? Right? What if we had that? Well, we would have in turn 65 to 35, would we not? But they wanted in reduced terms. Why would they ask for reduced terms? Because then they can limit you to one answer. If it's a numeric response, they might say A to B. What's A? Right? But if they don't say in reduced form, you could have 65, you could have 13, and you could have varying of them, right? Now, we want to be able to reduce this. So what we realized is we could take a 5 out of both of them and get 13 to 7. Yeah? Okay. Class example 3. So let's look at this one. We'll read it and then we'll see what you guys can do. So when placing bets on horse races, the chances that each horse will win are often quoted as odds. So they'll say this to this or this to this, right? And they give the odds of that horse winning. In a particular 5-horse race, the odds against, so we have to read here, odds against the horse winning. So which of these numbers in all of these represent winning? The first or the second? The second, because it says what? Odds against. When it says odds against, I look for what word comes after it, and that goes second. So odds against winning. So this would be winning, 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 winning. And what would the other ones be? Losing, or complement of winning. So we just write it as a W complement. But that's the same as saying losing. Yeah. Or not winning. Okay. So if I want to compare them and I want to find out which horse is a favorite to win, what am I going to look for? Anyone know? Yeah. We don't want to do odds because the odds are just reduced, and the only way we can compare odds directly is if they totaled the same value. Right? Do they total the same value? No. So it's really hard actually to compare odds. Very, very, very hard to compare odds because they're not of the same total. However, we could turn them all into what though? And then they would be out of a total, and we could turn into a decimal at the very least. We could turn into fractions. We could turn into probabilities. If we turned each of them into the probability of winning, we could turn them into decimals, right? The fractions into decimals, and we could pick the highest decimal, could we not? So odds are great, but for like giving me an answer, but they're really terrible for comparisons. You have to turn them into probabilities. So what would be the probability of Free Spirit winning? That is the horse's name. I feel like it should just win because its name is Free Spirit. It would be 1 out of 3. Why is it 1 out of 3? Because your odds add to total. And people do that all the time, right? Like it's just an easy way to error. And what answer are they going to have? 1 out of 2 for sure. They're going to have an answer to 1 out of 2, right? So we're going to make sure. So then what about this one? Willow. Probability of winning would be 1 out of 4. And then Foxtrot, probability of winning, 2 out of 7. And Gloria, I think Gloria should win. I think that's my favorite. 1 out of 9. She's not doing very well. Lucky Joe is the saddest out of all of them because he's 1 out of 12. Now, if they're hard to, because do any of them actually have the, what did I mess up? Is 9? No. That's from Simpsons. Okay, we're bringing in Simpsons, Family Guy, all these great things. Okay, so right now they're hard to compare because they don't have the same denominators, right? Hence, they didn't have the same total, right? But I can turn them all into decimals. So 1 divided by 3, you just go 1 divided by 3 in your calculator, and what do you get? 0.33, it keeps going, right? 1 divided by 4, what's 1/4? 1.25, or 0.25, sorry. 2 divided by 9? 1 divided by 9? And 1 divided by 12. So which one has the best chance of winning here? Huh. Well, I really liked it first, and then I heard more names and liked more. Free spirit. Because it's 0.33 to the nearest hundredth, or 33%, 25%, 22%, 11%, 8%. So which horse is the favorite? Free spirit. What is meant by the phrase zero odds 2 to 1 against? 2 to 1 against. What if it was 2 to 1 against winning, let's say? Every 2 non-winning to 1 winning, right? If it said odd against winning, winning would be here, not winning would be here. So to every 2 not winnings, they would win once. That's what the odds are, right? Or you'd have a 2 out of 3 chance of not winning and a 1 out of 3 chance of winning, right? So the catch is that odds is tricky. It's just that I can ask it in so many different ways. I can ask for the probability from an odds. I can ask for a different odds from an odds. I can ask for a different probability from an odds, right? I can ask which one's better, and I can give you odds and probability mix. So on tests in the past, there has been questions where it asks you which is the best one, and it gives you probabilities and odds mixed. Well, you have to decide, do I have to make them all odds or do I have to make them all probabilities? Because they have to be the same thing in order to compare them. Which one's better to compare, odds or probabilities? Probabilities are always better. So if they give you a probability odd mix, you will turn everything to probabilities, because probabilities can be turned to decimals and you can compare them, correct? Odds, unless they're out of the exact same total, are hard to compare. Make sense? Okay, I want you guys to do the assignment 1 to 15. The answers are at the back. If you do not get the correct answer, please call me over because I want to figure out why you're making mistakes, because that's the catch on here. This is a benefit to you. Not to just write the answer, the correct answer, but to actually ask why did you get it wrong if you don't know. Yeah.